morning, everybody. If you've been watching this video series, you've been watching me make a polycarbonate or plastic bending brake out of MDF and some aluminum parts and some stuff I got from Home Depot and some random parts I found in my workshop. We're getting there. We're almost done. Something arrived in the mail today. This. We're going to open this up in a little bit and see what's inside of it. But I have a feeling it's my power supply to heat up the nichrome wire that runs through the middle of my cold bending brake so we can turn it into a hot bending brake. So we're going from a cold bending brake to a hot bending brake, or something with a power switch. And it should be fun to get this to work. I've been slowly increasing the power through a strip of wire that is about 20 inches wide. And I've been finding that I can heat up a small element about that wide really hot, but I can't get one that wide really hot. I can get it hot enough to burn me, but not hot enough to, say, melt polycarbonate. So that's what this is for. This is to get the wire hotter at a longer width. And we're going to get there later on in this video. Building the bending brake was a lot of fun. It does take a little thinking, and sometimes to get the parts to work, you need to make some adjustments. I had to drill my holes a little straighter and add some giant washers to the bottom of the MDF here. And with that being done, I was able to get the brake part, this metal brace, to spring back, which is terrific. So now I can put the washers on it and spin the wing nuts back on it, and we're good to go. So, hey, you know, I actually got the cold part done, which is wonderful. And I tested it, and I was able to bend a couple of polycarbonate sheets, and it did a pretty good job. You know, that's wonderful. So a quick demo. The way your brake should work is as you spin the angle iron down, it should slowly compress to the point where it's squeezing. Looks like it caught there. Yeah. Looks like it's got a little bit of a problem where I have to do it really evenly. You want to spin that down. Oops, caught again still. I wonder why. Well, nothing's ever perfect. Is the spring jammed? Did I jam that? There we go. Nothing's ever 100%. But sometimes you just have to work out the issues. So you can see here that I've compressed it. And if I slipped a piece of polycarbonate in there, this would hold it down. So let's back it off a little bit. Now, there's a couple other pieces of metal you can stick in here to kind of help things along. You can stick a piece of sheet metal in here so that you get the bend point right where you want it. That's going to help a little bit. Another thing you can do is you can make yourself a 90-degree piece of sheet aluminum like this that I can slide underneath to give this a better edge. And I'll show you that with a close-up. So here I've cut out this piece of aluminum, so this was part of that. Slide it in under here. And this allows you to slide out the bending corner. So you're bringing the bending corner forward a little bit. So if this is the front and that's the back, we're going this way. Now, it kind of sits on the hinge. And the wire is going to be right here. So you could put it on top of the hinge like that, and it would still work, and you could still clamp down the plastic. But it's going to work best by locking that down against the hinge right there, and then locking down the brake onto the polycarbonate. And that's going to work just fine. It's not super elegant, but that's how it looks. And over here, you can see how the angle iron is sitting on the plastic. Let's take a look at it with a piece of polycarbonate in there. I got a piece of sheet steel out of the garage to show you how this is going to work. To keep from marring up the wood and creating deformations there, use a piece of sheet steel. Slide it under there, get your polycarbonate under the brace, and bend it up. So that's a cold bend right there. Later on, we're going to do a hot bend. One of the things I did was on the angle iron or L-beam on the brace. Okay, this is on, sorry.
Bender video, take 2.
One of the things I did to the L-beam on, start again.
Bender video, take 3.
One of the things I did to the L-beam on, start again.
Bender video, take 4.
One of the things I did on the L-beam, or the angle iron made of aluminum, on the brake is I notched out either end of the beam. That's to fit the hinges. It looks like I'm going to have to take this other piece and do the same. This time, I'm just going to take it at a 45 and notch out this piece at a 45. So what I'm doing here is I'm getting the mechanicals working and I'm getting the electricals working. Once I have the mechanical part working the way I want it to, and then I get the electrical part the way I want it to, I'm going to put them both together and get the whole thing working as one giant hot brake. You can see there, I just notched that out a little bit. Same thing over here. Using a file. I could have used a saw, but a file works just fine. You're not just going to make your bending brake with this part. You're going to have this piece and this piece, giving your bending brake the ability to make really good 90-degree bends, or 45-degree bends if it's cold, because when you do this, you have some spring back on the material. Now, if I do it without this piece, so I can feel that that's pretty snug. So I'm going to move the L bracket out of the way, put it aside, move my breakfast, and do a quick bend. Now, you'll notice that as I bend, I'm not really at the bending point. See how the plastic's kind of moving funny there? Do I get a bend out of it? Yes, I do. I still get a cold bend out of that polycarbonate. Just so I don't scratch it up, I'm going to take this out. So, did I break it? No. I cracked it in the corner a little bit. Maybe because this part's a little sharp and I should round it a little bit. The only way you're going to know is to test it. So here I have the L-beam pushed over a little bit. I've reinstalled some polycarbonate, and I'm just going to try another bend with it. So we're comparing with the L-beam and without the L-beam. That seems to be a little bit better. You can see there that I got a better look out of it, and it didn't tear the corners. So maybe that's a better idea, to use the L-beam than to not use the L-beam. Nice job. Nice job. Let's see what's in here. I am quite sure that this is the power supply I ordered. It could be the Spaceballs action figures that I've been dreaming about for the past 10 years, but I seriously doubt that. About the right size for a power supply. Okay, that's a packing list right there. Does it come with instructions, I wonder? The answer is no, it does not. Now, I have a couple simple rules when I work with things. Things that are bigger are usually more powerful. Things that have a lot of heat, dispersion devices, or a lot of venting going on, they're generally more powerful too. So I got to be real careful with this thing. There's no instructions, so I'm going to have to go online. My guess is that there's probably an AC input over here and then maybe an output over here. So I'm going to have to hook up an electrical wire to the wall, 120 volts or 110 volts here. People are always confused about that. Is it 110 or is it 120? Okay, it's 110 or 120. It depends on who you ask, but it's about 120 volts. That's the US standard. And then your voltage output, which is, 36 volts or whatever it is, 6 amps, and a knob, which is pretty basic. This is not going to be all that difficult to work with, and we should be able to get this hooked up pretty quick and start testing the heating elements. When you're working with this stuff, always go online and look up the instructions. This device is used for other things other than, say, heating up wire. There's a switch on the side for 220 or 110. I'm going to have to throw that switch. And I have black, white, and green for the wires, which means this old crappy cord is not good enough. I'm going to have to get a 3-prong cord for safety. The question becomes, okay, most devices work on 2 wires, right? You can plug anything like Christmas lights into the wall and it'll work. Why 3? Well, depending on your sources, if you're working with a 2-pronged wiring system, and for some reason you touch the wrong thing at the wrong time, and the ground line, okay, so that, that would be one of these 2 on the left. If that ground line isn't fully connected or is loose, the electrical pathway might go from your finger to your heart to ground, meaning you could stop your heart. So that's why when you have 3 wires, you should use 3 wires. That extra ground gives the circuit a different pathway, so the electricity won't go up your finger, up your arm, and through your heart. And that's important to understand when you're working with electricity. There's 2-prong plugs which work, and they're fine, and everything is okay most of the time. But if something goes wrong, you want 3 prongs to give that current another route, another good complete circuit for that current to go through. So if it chooses a pathway, it'll choose the more complete circuit first and not choose your body. So that's important to understand about electricity, is it seeks pathways of least resistance. And that's why you have 2-prong plugs and 3-prong plugs. When you're working with this thing, the first thing you should do is find the 230 volt switch and switch it to 115. Now isn't that something? You know, some things say 110, some things say 120, some things say 115. Well, this thing's made in what, Type A? There's really 2 standards. There's the lower 100 volt standard, and then there's the higher 200 volt standard. And there are circuits, home circuits, that run on 220. So it's just not so powerful that it can electrocute you and kill you. Yeah, dangerous. You should be careful when you're plugging stuff in with a 220 home outlet. But people get shocked all the time, and it's not super dangerous. So remember, power is more than just voltage. It's voltage and current. And that's what makes up the power, which is the thing that can harm you. Remember that. Sometimes you just need to ride to the home improvement store and pick up some wire. Yes, I know it's raining. Throw it in your trunk. Make sure it fits. Always just enough room. I'm going to apologize a bit because my phone is still wet, but there's a number of cords you can choose here at the home store to actually do the job. You're not going to need that big one over there. That's ridiculous. But you can probably get a cord like this, 13 amp, and put some connectors on it, and that'll work just fine. So here, for a lot more money, they put some connectors on the end, and they give you a little bit more power, about double. So, that's not really what you want here. You're not really messing with a lot of power. So you can go for the cheapest cord possible. 13 amp should be fine, and everything should work just dandy. And then ride home in the rain. Back again with the heavier power supply and running some quick tests. Ooh, The wire is still expanding. Okay, so where are we today? Well, I have the newer power supply, which is this thing out of Asia, which is the LRS 150-24 power supply. It varies between 20 and 30 volts, and I don't have control over the current. But there's a little tiny knob on the right, and if you turn that with a screwdriver, you get either 20 on one side of it or 30 on the other side of it. So there's some adjustability there. Funny thing is, okay, these control knobs, they're just like stereo knobs. You go counterclockwise down to 0, and you go clockwise up to the higher numbers. Well, as I increase the voltage, I get less glow. As I lower the voltage, I get more glow. I'm going to show you that here right now. So if I turn it clockwise to increase the voltage, I get less glow, less heat. I go down in voltage, and the glow increases. That almost sounds counterintuitive. Why is that? It's because the amount of heat it generates isn't based on voltage. It's based on current. And because of that, okay, so I don't have control over the current, but I'm feeding steady current in. Some of that current is released as heat. And the current that's coming out is variable with the voltage. Ooh. Oh, if the wind blows, it gets cooler. Like, why did it stop glowing? Because the wind blew. Okay, so subject to wind, okay, you're going to get differences in temperature, but it seems to be stable. So that element is hot enough for me to make my bender. And it is a certain length, which is nice. I also noticed that this power supply isn't perfectly stable. It tends to oscillate a little bit. But it works. So the car battery tender, not so much. I get about 5 or 10 inches out of that at most. But I can get a lot more out of that by using this power supply. Now, this power supply comes in various models. You can get bigger ones, smaller ones, ones that are more powerful, but this is a great start. Now, I also bought different thicknesses of wire. Thicker wire doesn't seem to work so hot, but the thinner wire seems to generate the heat, which is interesting. Okay, so wire diameter seems to play a role in this. That all being said, I was given different thicknesses of wire. I have this one, and these wires are supplied in different thicknesses, so you can test them for a certain result, just in case you're trying to create a heating element, because you don't know how much current your device is putting out. Now, funny thing, I have this super thin wire here that I want to try. So what I'm going to do is I'm going to unplug it and see if I can plug in this really thin wire and see what happens using the same setting. So I've just unplugged it. Now, I said something earlier that these devices, even when they're unplugged, can be dangerous, especially when you're messing with them, is that they can carry current when you're unplugging them. And if you stick a screwdriver in there, you can get a hell of a zap. Okay, that's warm, not hot, but warm. Now this is a super thin wire. Okay, so thicker, thinner, super thin. Now I just want to kind of shove that out of the way there. And I'm going to try and get this to clip on properly so that it makes a good connection. There it goes. So now we have this little teeny tiny wire in here, and I'm going to plug it in. See what happens. It should go poof. rather quickly. Got a color change out of it. Let's try doing a change here. That's cooler. That's hotter. So going down means more heat. And I can see that when I cranked up the voltage, lowering the current, the wire got cooler. It actually changed shape. But is it producing enough heat to make my bender work? And the answer is no. The thin wire does not seem to be the answer for this power supply. There seems to be a certain optimal thickness which seems to give me the heating element that I want out of this, which is that wire sitting over there on the side of the project. So let that be a lesson to you. You need different sized wires to play with, and you need a couple different power supplies to play with in order to get this right. When preparing to install the heating element or nichrome wire, the first thing you should do is create some kind of a mounting bracket on either side. And you want to make sure that it's 100% aligned. What I did was I got two different kinds of metal. One is steel and one's aluminum. And I made sure that they weren't touching the aluminum central channel. I bent them to a 90 degree and then drilled a hole on either end. Then I made sure that the hole was lined up 100% on either end. Then I came up with a way to put one of these eyelet type hooks, right? So it's an eye hook through either end so that you can tension the wire. Now the wire is always going to have a little bend in it because there's a spring that's giving you a lot of the tension. Okay, so once you get these eye hooks or eyelet type bolts through that hole, okay, you're going to have a system where you can bring up the tension on either end just by using a couple of nuts. Now this is setting with some 6-minute epoxy, so that's going to have to dry a little bit and cure, and when it's done I'll be able to grind off the excess or scrape it off, then bolt in or nail in either piece. This is going to get some flathead nails because of the tolerances. That one's going to get some screws, and we're just going to try it two different ways and see what happens. But what's holding it in place is the epoxy, not the screws. So the nails and screws are more or less for show. But you'll be able to put a lot of tension on that if you want, or just use the spring so that you can use the spring to control the expansion and contraction of nichrome wire at either end. I'm just going to use one spring on one end, which is that end over there, which is the longer end. And this end is going to have this eye bolt through the hole, and I'm just going to twist the nichrome wire around that bolt, and it's going to sit flat like that. And that's going to give me the clearance I need to run that wire under these hinges and through the channel. Isn't that cool? Just gotta wait for it to dry, that's all. Oh, and one little thing. If you put your elbow into the epoxy while it's curing, grab some QD electronics cleaner and a paper towel and wipe it off your elbow. Yeah, I got most of it off. But there's a big 4-inch blotch of epoxy on my elbow.
What did I say?
This is Christopher Thunder, and I'll see you next time. To align the heating elements perfectly, stuff small pieces of insulation around the heating element. Ah, crap. What the hell?